Welcome, and thank you for joining us today as we introduce RoboSep-C, our new automated closed instrument for large-scale human immune cell isolation. My name is Amanda Vandenhoek, and I'm joined today by one of our senior scientists, Vesna Pasarek, whose team has been instrumental in developing this system here at Stem Cell Technologies. Today's presentation will cover four main topics. Very briefly, we'll introduce you to Stem Cell as a company and what solutions we provide for immunology researchers. Then we'll dive into the main focus of today's presentation, the challenges of large volume human immune cell isolation and how RoboSep-C has been designed to address those challenges and ultimately help streamline large sample processing. Our goal is that by the end of today's presentation, we've provided you with clear answers to all of the questions shown here. So let's dive right in. As many of you already know, Stem Cell Technologies is a global biotech leader, and we've been developing innovative, high-quality reagents and tools for over 25 years to support many different areas of life science research. But what we're going to focus on today, and what you, like Vesna and me, are all passionate about, is immunology research. As you all know, primary human cells can be a valuable tool in conducting physiologically relevant immunology research. And here at Stem Cell, we've worked hard over the years to ensure that the products we develop support every step of immune cell-based research, from sourcing of primary cells to cell isolation, activation, genome editing, cell expansion, and analysis. In order to provide a foundation for the rest of today's presentation, it's important for us to introduce you to some of our existing cell isolation technologies, specifically our immunomagnetic approaches, RoboSep and RoboSep. For those of you who may not be familiar with RoboSep, this technology combines the specificity of monoclonal antibodies with the simplicity of a column-free magnetic system. The result is an incredibly fast and easy protocol for isolation of highly purified immune cell populations. And as you can see here, the protocol really is as simple as adding RoboSep reagents, both your antibody cocktail and magnetic particles, to your cell sample, incubating their labeled sample in an RoboSep magnet, and then simply pouring or pipetting off the supernatant to separate the labeled and unlabeled cell fractions. Human immune cells can be obtained in as little as 8 minutes, and mouse immune cells can be obtained in as little as 15 minutes. The RoboSep portfolio that we've developed over the last 20 plus years has been used by thousands of researchers worldwide and works robustly across a wide variety of species and starting samples with different selection methods and magnetic platforms available depending on the sample volume and the number of samples you need to process. RoboSep technology can also be automated using our family of RoboSep instruments, which are all designed to minimize sample handling and free up your time to do other things in the lab. Here, the instrument performs all of the cell labeling and separation steps. You simply have to load the reagents and select the appropriate protocol. Up until recently, we had two main RoboSep instruments, RoboSep-S, which automates cell isolation from 1 to 4 samples at a time, and RoboSep-16, which, as the name suggests, can process up to 16 samples at a time. The newest member of our RoboSep family, and the focus of the presentation today, is shown here on the right, RoboSep-C, which has been designed not for simultaneous multi-sample processing like our other instruments, but rather for processing of large volume samples. There are a number of applications where processing large sample volumes is not only quite common, but actually a critical part of the workflow, primarily in areas like biobanking, drug discovery, and immune cell therapy research. In these areas, the use of primary human immune cells is an incredibly important tool for ensuring the physiological relevance of the research that's being conducted. And compared to cell lines, primary cells more accurately reflect the inherent variability in donors and samples, which in these cases is actually a good thing. And this allows them to facilitate translation of basic research into preclinical and even eventually into clinical applications. And leukapheresis samples, or leukapaks in particular, are an excellent sample source as they can provide large numbers of single donor mononuclear cells from peripheral blood to ensure enough cells for use across a multitude of downstream assays. And while many groups perform preliminary work with smaller sample volumes, most groups in these research areas eventually do need to scale up to larger sample volumes, like leukopaks. But efficiently isolating cells from an entire leukopak can be tricky, and there are some considerations that are unique to processing them, namely ease of use, protocol speed, performance, and integration with existing downstream applications. Most cell separation systems have been designed and really optimized for use with these far larger or smaller volumes of blood, typically in that 1 to at most 50 ml range. But a leukopak can be much, much larger than that. 100 to 200 mils is quite common. They can even go larger. And so to effectively facilitate this scale up to these large sample volumes, a really good system for processing leukopaks needs to be easy to use with those larger volumes. Protocol speed can also be a really big factor when you're working with such large volumes, as it takes time to process that amount of sample. And most importantly, the system needs to deliver the same highly purified functional cells that you were obtaining previously at the smaller scale to ensure that the results of your downstream applications translate appropriately as your research scales and progresses. And when working with these larger volumes and in these specific applications, many groups turn to automation because an automated closed system can reduce operator error, reduce the risk of contamination, and just generally increase the robustness and reproducibility across samples. And at Stem Cell, we've worked hard to develop a system that incorporates all of these elements to streamline leukopak processing. RoboSep-C is a new isolation platform that automates immune cell processing from leukopaks, performing all of the steps involved in sample washing, immunomagnetic cell isolation, buffer exchange, and cell concentration. Through automation, we've minimized the hands-on time required so that you have more time in the lab to do other things. Our closed system design uses simple, single-use tubing sets to ensure both product and operator safety. Our gentle protocols yield high-quality cells and remove the harsh manual wash and concentration steps that are used by some other systems. And most importantly, instead of spending all day isolating cells, RoboSep-C can isolate cells from a full leukopak in less than 90 minutes, meaning more time for downstream assays and even increased capacity to process multiple leukopaks per day with a single instrument. All right. What I'm going to do now is pass things over to Vesna so that she can walk you through the details of this new system and how it can streamline large volume sample processing in your lab. Off to you, Vesna.
Okay, thank you, Amanda. So I'd like to start my portion of the talk by giving you an overview of the RoboSep-C instrument and really focusing in on some of the key design features that enable automated large volume cell washing and isolation. So firstly, we have the scale tower that supports the sample, buffer, and tubing set bags. Next, the pump module, along with the cassette clamps, work in tandem to move fluid through defined paths as specified by the protocol. We also have the cell wash mount, which holds the cell wash cartridge of the tubing set and enables gentle cell washing, concentration, and platelet removal. Another key feature of the design is the primary and secondary magnets, and these are specifically designed for large volume separation of immunomagnetically labeled cells. And as the instrument runs, it's monitored by a number of sensors, and these include the weight, the pressure, and the fluid sensors. And these work together to ensure that the protocol is running as directed by the software. Finally, the touchscreen guides the user through the setup of a RoboSep-C run and displays the system status during the automated procedure. Now, the RoboSep-C was designed to work together as a system that's comprised of all of the components that are required for a run. This includes the RoboSep-C tubing set, which is shown here as a schematic overlaid on the face of the instrument. So the single-use set provides a closed, sterile fluid path for cell washing and isolation. Some of the key components I'll point out are the cell wash cartridge, the primary magnet chamber where magnetic separation occurs, and the various in-process bags that are used throughout the procedure. The system also uses a RoboSep-C buffer, and this is a 3-liter bag of PBS containing 1 millimolar EDTA. Now for the cell labeling, this is done using the RoboSep-C isolation kits. These are comprised of 2 10 ml vials of reagent, so 1 vial of antibody cocktail and 1 vial of magnetic particles. And each kit processes 10 billion nucleated cells total. For our initial launch, we have 3 negative selection kits available, the T cell, the CD4 T cell, and the CD8 T cell isolation kits. And we are actively working on developing new kits to isolate additional cell types that are of interest to immunology researchers. And then finally, of course, is the starting leukopak sample. And the RoboSep-C can process between 2.5 and 20 billion cells per run. So anywhere between a quarter to a full leukopak size sample. So now I'd like to spend a few minutes going over the fast and easy RoboSep-C workflow for T-cell isolation. The protocol consists of kind of 3 main components. So firstly, the system setup, the automated run, and finally the sample collection. So I'll just note the layout of these protocol slides. In the bullet points, you'll find a list of steps that the user takes to set up and run the system. And in the gray box are the steps the instrument automatically performs as a part of the RoboSep-C protocol. So the first step to setting up the system is to turn on the instrument and select the protocol based on the cell type you wish to isolate and the number of cells in your leukopak sample. Next, the system will prompt you to install the tubing set, and all of the set components pictured here are arranged in a tray in the order that you load them onto the instrument. And this really makes tubing set installation a quick and simple process that only takes a couple of minutes. After the set install, the user then prepares the RoboSep-C buffer by adding either FBS or HSA to the bag, connects it to the tubing set via a filtered spike port, and initiates the priming sequence. Next, you'll be prompted to load the cocktail and particles, and these are going to be added based on the number of cells in your starting sample. Finally, you'll load the leukopak sample onto the instrument and press OK to initiate the automated run. So each of these steps in the setup process includes an instrument check. So the instrument will complete checks to confirm, number 1, the instrument function, secondly, the correct tubing set installation, and then finally, that all of the required components of the system have been added to the instrument. So at this point, with the setup completed, the user is free to walk away as the fully automated procedure for cell washing and isolation by negative selection proceeds. So just a little bit about the automated procedure itself. It begins with the leukopak wash and cell concentration. So to wash the cells, the leukopak and buffer is circulated through the cell wash cartridge, which is pictured in this slide. And the cartridge contains a spinning membrane with 4 micron pores. So anything that is smaller than this pore size, including the supernatant and the platelets, is directed to a waste bag, while the retained leukocytes are concentrated and suspended in fresh RoboSep-C buffer. So this method is called spinning membrane filtration, and it offers a couple of major benefits compared to centrifugation. Firstly, it's gentle and non-pelletizing to cells, which means your viability will not be compromised. The second advantage is that this method consistently yields very high leukocyte recovery, so you're not losing your cells just to the sample wash. So after the cell wash process, the cells are then ready to be labeled with the RoboSep-C reagents. So first, the antibody cocktail targeting the unwanted cells, in this case non-T cells, is pumped to the sample. After that, the magnetic particles are added, and these will cross-link to the antibody-labeled cells, thereby immunomagnetically labeling all of the unwanted cells in the sample. Following labeling, the cells are then pumped into the separation chamber, pictured on the left, and the primary magnet will drop over the chamber for the magnetic separation. Following the separation, the desired cells are then pumped out of the chamber and will pass through a secondary magnet that's pictured in the photo on the right. The secondary magnet will capture any residual labeled cells that may have escaped the primary magnet, and this ensures a very high purity of your final sample. So with the cells of interest now isolated, the final step in the procedure is the isolated cell wash and concentration. This process, again, will use the cell wash cartridge, and if desired, allows the user to hook up a second buffer to do a final buffer exchange. So for example, for reformulation of their T cells in Immunocult XF T cell expansion medium, or another cell culture medium of their choice. Now, once the automated run is complete, the instrument will alert you to collect your isolated cells by simply sealing off the isolated cell bag and collecting it off the instrument. All that's left to do at this stage is discard the tubing set and either turn off the instrument or select a new protocol for the next run. So the total time of this entire workflow is just 75 minutes. About 25 minutes of this is hands-on time, with 50 minutes for the fully automated protocol. Okay, so now moving on to the performance data. In this slide, we show the purity, recovery, and viability that's obtained with RoboSep-C isolation from 16 different donors with each of the 3 T-cell kits. Looking at the purity on the left, we saw consistently high purities, averaging 95% for the T-cell and CD4 T-cell kits, and 90% for the CD8 T-cell kit. In the middle graph, we show the recovery of the target cells. And likewise, you can see a very good recovery for each kit with about 50 to 70% on average, depending on the particular kit. Finally, in the graph on the right, we're looking at viability. And again, we're seeing consistently high viability in the isolated cells that is comparable to the starting sample. So now looking a little bit more closely at the enrichment efficiencies you can expect from a RoboSep-C isolation, we show here examples of flow plots before and after isolation with each of the 3 T-cell kits. So on the top left, we have the T-cell isolation, and you can see starting with a 66% CD3 positive population in the leukopak, we see a 97% purity following T-cell isolation. Similarly, looking at CD4 T-cell isolation on the bottom left, we see an enrichment from 32% in the start to 95% CD4 positive T-cell population following isolation. And then finally on the right, in this example, 17% of the starting cells were CD8 positive T-cells, and after isolation with the CD8 kit, the CD8 content went up to 93%. So we also performed a flow-based assessment of the contaminant populations by staining for the major leukocyte cell types in the isolated fractions. So each of these graphs shows the percentage of contaminating cell types present following isolation with one of the 3 T-cell kits. You can see that in each case, very few residual non-target cells remain, and the isolated populations are highly pure. Next, we looked at the residual red blood cell and platelet content following RoboSep-C isolation. So looking firstly at the RBC content, we know in a typical leukopak, RBCs will outnumber white blood cells by a ratio of about 2 to 1 or greater. Following isolation, you can see in the graph on the left, a very low residual RBC content, below 1 to 2% on average. Likewise, the RoboSep-C procedure results in a significant reduction of platelets. So this amounts to about a 3 log depletion. And platelet depletion is achieved through both the cell washing cycles of the cell wash cartridge, as well as the magnetic labeling of platelets by the RoboSep-C kits themselves. And finally, here's an example of RoboSep-C isolated T cells that were activated and expanded using our Immunocult activators in T cell expansion medium. So in the table on the left is the cell assessment pre and post T cell isolation. It shows high purity, recovery, and viability of the isolated samples, and an unchanged CD4 to CD8 ratio compared to the starting sample. These RoboSep-C isolated T cells were then activated and expanded in a 10-day culture. And in the middle graph, looking at the expression of the activation marker CD25, you can see that both the CD4 and CD8 T cells are highly activated when stimulated with our immunoccult activators. Finally, on the right, we see a very high total fold T cell expansion over a 10-day culture in immunoccult T cell expansion medium. Now, cell activation and expansion are just a couple of the many possible applications that can be performed downstream of the RoboSep-C. The RoboSep-C has been designed as a standalone cell separation instrument. And that means that, unlike with other systems, you're not locked in when it comes to downstream applications. You're free to leverage the speed and efficiency of the RoboSep-C while continuing to use the downstream protocols you've already spent time optimizing for your specific applications. And finally, I'll wrap up with our key takeaways as we introduce this new platform. So the RoboSep-C automates immune cell processing from leukopaks, and this includes sample washing, immunomagnetic cell isolation, buffer exchange, and cell concentration. The procedure requires minimal hands-on time. The closed system ensures product and operator safety. The process is gentle on your cells, and the instrument is fast and easy to use. So that takes us to the end of my presentation, and I'd like to thank you all for your time. If you're interested in receiving more information about this system, please contact us or visit us at stemcell.com.